Hello everyone, I am Dr. Sunil Shingade and I am presenting here the presentation on project engineering. We considered three projects here. The first one is a continuous powder mixer. The second one is the recovery of carbon disulfide and the collection of hydrogen sulfide from the viscose process. And third one is the commercialization of ultrasonic assisted cavitation on an industrial scale. This is the first is continuous powder mixer. The flow chemistry is an emerging field in chemical industries, mostly in pharmaceutical industries. Therefore, mixing operation of the various powders should be in the continuous manner. This one is the batch mixer, in which these are the internal paddles which rotates and mixes the various powders uniformly. And once the mixing takes place uniformly, then the powder can be removed, the mixture of the powder can be removed from the bottom side or bottom section. The goal of the project is to design the continuous powder mixer. Here we considered three powder mixers, various powders, which we have to mix continuously. The separate screw conveyor is used to load each of the powder inside the mixing chamber. The capacity of the powder carrying capacity of each screw conveyor is depends upon the speed of rotation of the screw conveyor, means frequency of the screw conveyor. As the frequency of the screw conveyor increases, the conveying capacity of the powder increases. Once the mixing section consists of three parts. First one is the loading section. The second one is the mixing chamber, which consists of central shaft on which the paddles are assembled. This system is slightly inclined to the horizontal part, and this mixing chamber is externally attached to the tooth wheel to rotate. Therefore, the powder gets slid down. While the powder gets slid down, the internal paddle rotates at higher speed and carries out the mixing of the loaded powders. And the final section is the unloading section, from which the mixture of the powder can be removed continuously. The specific features of the continuous powder mixers are as follows. The assembly of the continuous powder mixer consists of separate screw conveyors to convey each of the powders separately before going to load inside the mixing chamber. Powder carrying capacity depends upon the rotating speed of the screw conveyor. Mixing chamber consists of three portions. First one is the loading section, second one is the mixing section, and third one is the remove section. Loading section is that section in which powder can be loaded and carried further by screw conveyor. Mixing section is the rotating section, and powder gets slid down by rotation. It consists of the rotating paddles assembled on the central shaft for carrying out the mixing of the multiple powders. The baffles are provided on the central shaft to prevent back mixing to the extent of cross-sectional area fraction occupied by the baffles. These baffles are like this one. This is the central shaft, and baffles having these tubes, circular tubes, and opening between, and this is the space between the tubes. Therefore, the back mixing can be avoided to the extent of this much area fraction occupied by these baffles. The separate motor is used to rotate the central shaft at high speed to carry out the effective mixing. Rotating chamber rotates with the means of the externally attached tooth wheel so that powder gets slid down. The speed of rotation of the mixing chamber is less than the speed of rotation of the internal pedals. Removing section is used to remove the mixed powder continuously. Then the other project is this recovery of carbon disulfide along with the collection of hydrogen sulfide in the viscose process. Viscose process is used to manufacture the cellulosic fiber from the softwood pulp. Carbon disulfide is generally used to break down the inter and intramolecular hydrogen bonding between the cellulosic molecules by forming cellulose xanthate so that cellulose get dissolved or pulp get dissolved into the caustic solution and form the viscose dough of having the desired spinning properties. And this is the present spinning bath in which aqueous sulfuric acid, aqueous sodium sulfate and aqueous zinc sulfate are going to allow to enter into the spinning bath from the bottom side. Sulfuric acid is necessary to neutralize the caustic of the viscose dough, caustic content in the viscose dough. Sodium sulfate is necessary to absorb the water from the viscose dough, and the zinc sulfate is necessary to give the softness of the cellulosic filament form. Once the cellulosic filament gets regenerated, the carbon disulfide gets released out. The boiling point of the carbon disulfide is 46.2 degrees Celsius and the temperature of the spinning bath is in the range of 50 to 55 degrees Celsius. Therefore, the temperature of spinning bath is higher than the temperature of or the boiling point of carbon disulfide. Therefore, carbon disulfide gets evaporated from the top surface of the spinning bath. Carbon disulfide is having adverse effects on the human health. It causes dizziness, poor sleep, headache, anxiety, weight loss, vision changes, and it is harmful to kidneys, blood, heart, liver, nerves and skin also. It damages the reproductive system also. And the other thing is, carbon disulfide is the most expensive raw material being used in the viscose process. But actually it is not going to consume in the viscose process. It is going to use just to break down the inter and intramolecular hydrogen bonding between the cellulosic molecules, so that this cellulosic pulp get dissolved into the caustic solution and form the viscose dough of having the desired spinning properties. And once this cellulosic filaments get regenerated in the spinning bath, then this carbon disulfide gets regenerated and gets flashed to the open environment. But we have invented the new spinning bath in which we have sprayed aqueous sulfuric acid, aqueous sodium sulfate and aqueous zinc sulfate from the top instead of passing them from the bottom side. We are sprayed all these reagents from the top side. Therefore, the net flow of the liquid is in the downward direction, and that outlet is taken out by the siphoning action. Therefore, once the carbon disulfide get released out during the regeneration of this cellulosic filaments. Then it flows down with the flowing liquid. Then that flowing liquid is passed to the flash evaporator, where carbon disulfide and hydrogen sulfide can be separated from the liquid portion. The carbon disulfide and hydrogen sulfide can be collected from the top side of the flash evaporator, and the liquid can be collected from the downside. The carbon disulfide can be removed from the hydrogen sulfide by carrying out the condensation of the carbon disulfide, because its boiling point is 46.2 degrees Celsius. The features of the invented spinning bar: the input of all compounds are given from top. That is, the input of sulfuric acid, sodium sulfate, zinc sulfate is given from the top. The output is taken from the bottom via cycling action. The outlet is provided to the gas liquid separator to separate carbon disulfide and hydrogen sulfide from the liquid. Carbon disulfide separation from the sulfuric acid from the hydrogen sulfide can be carried out by carrying out the condensation of the carbon disulfide, and hydrogen sulfide can be collected in the form of in the gaseous form. The net liquid flow in the spinning bath is in the downward direction. Therefore, suspended solid particles can get settled down easily and avoids the contamination with cellulosic filaments. Carbon disulfide recovery avoids the adverse effects on the human body and improves the plant economy, because it is the most expensive raw material being used in the viscose process. Then the third one is the commercialization of ultrasonic assisted cavitation on industrial scale. When ultrasonic waves passes through the or propagates through the liquid, then compression and rarefaction takes place. During the rarefaction, local vacuum will get generated and the cavities get formed. But these cavities get burst during the compression. Therefore, local temperature rises to 5000 Kelvin and 1000 psi, and at a high pressure and temperature, the chemical activities of the chemical species coming into the contact of this or in the contact of the burst cavities get enhances. The chemical activity of the species which are coming in the contact of the bursting cavities increases, and because of that increased chemical activity, the reaction speed gets accelerated and reaction gets faster. But the direct contact of ultrasonic waves with molecules, liquid molecules, cannot change any or cannot affect the reaction speed, because the wavelength of the ultrasonic waves is larger than the molecular bond length, the bond length between the molecules. Therefore, the molecular activity cannot be changed. But due to the formation of the cavities and the bursting of the cavities results into high pressure and high temperature, and that high pressure and high temperature increases the chemical activity of the molecules, and therefore reaction gets sped up. But the problem in commercialization of the ultrasonic technology on a large scale or on an industrial scale or on commercial scale is that the dead zones gets formed between the propagating ultrasonic waves, and also the less energy efficient. This is the ultrasonic horn, and this is the ultrasound waves which are propagating. Once these ultrasound waves propagating, then the dead zones between the adjacent waves get formed, and therefore the complete liquid inside the big reactor cannot be sonicated. This is the major problem in implementing the ultrasonic assisted cavitation on an industrial scale. Then how to solve this problem? Come to the solution. This is the internal loop airlift ultrasonic reactor. Here, the outer section and the inner section. The inner section is open from the bottom side. Ultrasonic horns are assembled inside the inner section. These ultrasonic horns having the different dimensions, means different length, and the air is passed in that length or in that section. And once the air is passed in the inner section, in which the ultrasonic horns are assembled, the density of the fluid in that loop reduces, or in that section reduces, and the liquid from the outer section of having higher density circulates to the inner section, which is having the lower density due to the contamination of the air. And therefore, over the period of time, the entire liquid which is circulating passes through the vicinity of the ultrasonic waves or ultrasonic region. Therefore, the entire liquid can be sonicated or can get sonicated over the period of time. The outer section is having the baffles so that it can be mixed thoroughly in the outer section also. Then the other idea about designing the commercialized ultrasonic reactors is the external loop airlift ultrasonic reactors. It consists of two legs, and these two legs are connected each other from the top as well as bottom side. The ultrasonic horns are assembled in one of the legs in which air is passed. And once the air is passed, then the density of the fluid in that leg reduces and the liquid gets circulated from the leg of having higher density to the leg of lower density. And over the period of time, the whole liquid passes through the region of the ultrasonic sound waves and gets sonicated over the period of time. In such a way, ultrasonic system can be implemented on an industrial scale by avoiding the formation of dead zones and by sonicating the complete liquid over the period of time by passing or circulating the entire liquid through the region of the ultrasound waves over the period of time. This is the continuous ultrasonic reactors. It consists of two legs, external loop airlift continuous ultrasonic reactor. It consists of two legs. In one leg, the ultrasonic horns are assembled and in which the air is passed. As the air is passed, then the density of the liquid in that layer, in that leg decreases and the liquid gets circulated from the leg of higher density to the leg in which air is passed. The input is provided at the bottom and the entire liquid gets circulated with the circulating liquid and the outlet is taken from the top. Therefore, some liquid gets come out from the top and remaining liquid gets circulated. And therefore, the entire liquid can be sonicated with the period of time, over the period of time, and therefore the ultrasonic assisted cavitation can be implemented on an industrial scale. Thank you.